Okay, so in this example here, we're going to be talking about rational equations and checking for extraneous solutions at the end. So again, we are dealing with a rational equation here, and it's very simple to check for extraneous solutions, and I'll talk about that at the end. But you're simply just looking for any solution that is going to make your original equation undefined, meaning you'll have division by zero. And again, we'll talk about that at the end. First, let's talk about how we're going to solve for x here. And whenever you're given a rational equation, my recommendation to you, factor everything that you can. So starting left to right here, I can't factor my first fraction here. That's fine. I'm just going to go ahead and rewrite it. So if I do that, I get x plus 6 all over x minus 2. Okay. Looking at this fraction here, though, I can factor that denominator. So I get plus, and then I get 1 over. And you can use the AC method here, or you can factor it in your head. But however you do it, you should get x minus 6 and then x minus 2. Okay. So again, when I multiply negative 6 and negative 2, I get the positive 12 right here. And then when I add them, I get the negative 8. Again, you can do the AC method in your head, or you can write it out. Depends how you want to do it. So that one's done. And then looking to the right here, to the right of the equal sign, I have the same exact quadratic in my denominator. So all I have to do is rewrite these factors here. So I'm going to write equal to x minus 5 all over x minus 6 and then x minus 2. Okay, so that's completely factored. And then from here, you have to decide how you want to go about doing the problem. It's totally up to you. But how I would do it is I would take this fraction here and I would move it over to the right-hand side because I have the same common denominator on the right-hand side. And then the problem is going to be much easier to work. Now, another way in which you could do the problem, notice that you have x minus 2 here. So I pretty much have the same denominator when compared to this denominator here and this denominator here. I just need that x minus 6. So another way you could do it, take this fraction right here and multiply both the bottom and the top by x minus 6. That way you get a common denominator, and then you can go from there. But I'm not going to do it that way. I'm simply going to take this fraction here and I'm going to move it over to the right-hand side, meaning I have to subtract. Okay, so I'm going to go ahead and scroll down. And I'm going to rewrite this going left to right. So I get x plus 6 all over x minus 2. Now equal to, now think about what's going to happen here. You're going to subtract this entire fraction. That's going to make the 1 negative. So essentially what you're doing x minus 5 and then minus 1. Okay, so that will give me x minus 6. So I get x minus 6. And again, since I have the same denominator, I can write it underneath the same denominator, right? So it's going to be x minus 6. And then x minus 2, and we're good. And so from here, look at your factors because you're going to start having factors that will cancel out. So for example, this factor will cancel out, this will cancel out. And again, technically you're left with 1 on your numerator. So I'm going to go ahead and put this in parentheses, and you technically have a 1 here, okay? Is there anything else that will cancel out? And nothing will, but you have a proportion here. You have two fractions equal to each other. You can simply cross multiply. Right? So cross multiplying, you're going to go here and here, right? So I'm going to do x plus 6 times x minus 2. So how's that going to look? Well, it's going to be x plus 6 times x minus 2. No need to expand it out yet because you may have more factors that will cancel out, okay? Then you're going to put equal to, then going from here to here, I have to do x minus 2 times 1. That will give me x minus 2. So I get x minus 2. So what you have here is you have the same factor on both sides of the equal sign. If that ever occurs, you can simply cancel them out because essentially what's going to happen, you're going to end up dividing by x minus 2 here on both sides. So for example, if you divide by x minus 2 here and here, right, this will cancel, and they cancel each other out. So if you recognize that you have the same factor on both sides of the equal sign, you can simply just cancel them out. So that's what I'm going to do here. I'm going to cancel out x minus 2 and x minus 2. Now remember, you do have a 1 here, okay? So don't put 0 there. There is a 1. And then I'm going to rewrite the equation as x plus 6 equal to 1. And then finally, solving for x, you get x is equal to negative 5, okay? So I'm going to box that in, but you should check to see if it's going to be an extraneous solution. Meaning, if I take that negative 5 and I plug it back into the original rational equation, will it give me an undefined answer? Meaning, will you have division by 0? So all you have to do here is check your denominators. So if I plug in a -5 right here, will it make it undefined? Meaning, will I have division by 0? And I won't. If you plug it in here, will you get a 0? And the answer there is no, you will not get a 0. And same thing here, it's the same quadratic, so no, you will not get a 0 here, meaning -5 does not make this rational equation undefined, meaning it's not an extraneous solution, it is my solution, right? So x is equal to -5. All right, let's go ahead and try another example. All right, so here's another example, and again, it's up to you how you want to go about doing the problem. Now, me personally, I see that I have the same denominator here and here, so I'm going to take this fraction and I'm going to move it over to the right-hand side, and I'm also going to factor this quadratic here, okay? Remember, you should always try to factor before you do anything, and actually, I can even factor this denominator here and this one as well because I can pull out a greatest common factor, all right? So why don't we go ahead and factor everything first, and then we'll go from there. But again, I am eventually going to move this over to the right-hand side. So I'm going to write here x squared, and then I have the following. And we're going to do this off to the side, that way we can factor it. Looking at my quadratic, I can pull out a 4. So if you pull out a 4, right, what are you left with? Well, you're left with x squared minus 4x, and then plus 4, okay? So again, we can then factor this part here. I need two numbers when I multiply, that will give me +4, but add up to -4. So again, two numbers when I multiply, that will give me +4, but add up to -4. Well, that's going to be x minus 2 and x minus 2, right? So we just factored it. And again, that's using the AC method. We're doing it in our head. Now, a is equal to 1, this value right here. So I can put it right in factored form. So let me go ahead and get rid of all this here. Remember, I did pull out a 4. So I'm going to write here 4 in parentheses, and then it was x minus 2 and x minus 2. Okay, completely factored. Now, we could probably do this all in one go. We can move this over to the right-hand side and factor. So for example, I'm going to put equal to, and I'm technically going to start with this fraction right here because this will be to the right of it when I move it over, right? So when I move this over, this will be to the right of this fraction. So I'm going to start with the fraction that I have circled. Can I factor the numerator? I can't, so I'm going to rewrite it as 7x plus 6 all over. Now here you can pull out a 4. So I'm going to pull out a 4. So pulling out a 4, then you get x minus 2. And then moving this fraction over, it will be minus, meaning that's going to change the signs on your numerator. So this will become a -x, and this will become a +5, okay? So I'm going to go ahead and write that the following way. I'm going to say plus -x plus 5 all over. And again, I'm going to factor my denominator. I get 4 and then x minus 2. Okay. So again, technically, I can now combine this whole part here. They have the same denominator. I can combine the numerators and put it all underneath that denominator. So that's what I'm going to do. All right. So let me go ahead and scroll down a little bit. Combining the numerator, you're going to do 7x minus x. That will give you 6x. So let's go ahead and rewrite this part here. We get x squared all over 4 times x minus 2 equal to, and then from here, we're going to combine like terms. So 7x minus x, you get 6x. And then 6 plus 5, you get 11. So plus 11. Okay? Again, just combining my numerator. That's all I'm doing there. And then all over 4 times x minus 2. Okay? So looking at it, it doesn't look like we're going to have any factors right now that are going to cancel out. And that's fine. Okay? So what I'm going to do from here, I'm going to go ahead and cross multiply. And then we'll see where it takes us. All right, so let's go ahead and keep scrolling down. So we're going to cross multiply, meaning this is going here and this is going here. So when you do that, you get x squared, then you get times 4, and then x minus 2. Okay, equal to, I'm going to go ahead and put this guy in parentheses because again, I am multiplying. So in parentheses, I'm going to put 6x plus 11. And then I have times 4, and then times x minus 2, and then times x minus 2. So again, if you have the same factor on both sides of the equal sign, you can go ahead and cancel it out. So for example, I have a 4 here, and I also have a 4 here. Then I have an x minus 2, and I also have an x minus 2 here. All right, it doesn't look like anything else will cancel out. So now you have x squared equal to 6x plus 11 times x minus 2, okay? So what you have now is a quadratic. I can see that I have a quadratic. I see it right here. And what we're going to do, we're going to move everything over to the left-hand side. Before we do that, I'm going to go ahead and expand out what I have here, because I do have multiplication of two binomials there. So we're going to expand that out, and then we'll move all of our terms to the left-hand side. All right, so you have to do FOIL here. So scrolling down, and we are going to do this off to the side. Why don't we do it in a different color? Doing FOIL on these two binomials, you get 6x squared. Okay, that's first. Doing outside, you get negative 12x. Inside, plus 11x. And then last will give you negative 22. From here, go ahead and combine like terms, which I have here and here. You get 6x squared, then minus x, and then minus 22. Okay? All right, so from here, we're going to go ahead and rewrite the equation. It's x squared equal to 6x squared, and then minus x, and then minus 22. Okay? So we have to go ahead and move everything over to the left-hand side. That way we can set this quadratic equal to 0, and we can solve for x. So doing that, again, I'm going to do x squared minus 6x squared. That will give you negative 5x squared. So I get negative 5x squared. And then moving over this term right here, negative x, I get plus x. And then moving over negative 22, I get plus 22. Okay, all equal to 0. So from here, you have a quadratic, and you should try to factor it. If you can't factor it, you can always use the quadratic formula, but try to do the AC method on this quadratic. So if you do a times c, what does that give you? So a times c, that's going to be negative 5 times 22. That's going to give you negative 110, okay? So what you need here is two numbers when you multiply that will give you negative 110, but add up to your b, which is 1, right? My b value here is 1. Well, that's going to be 10 and 11, but one of them has to be negative. So it's going to be positive 11 and negative 10. When I multiply them, I get negative 110. When I add them, I get 1. Okay? Now, here's the deal. Your a value right here is not equal to 1. So we have to go ahead and do factor by grouping. All right? So why don't we go ahead and do that? I'm going to go ahead and erase some of the work that we have here. That way we have room for factor by grouping. And from here, I'm going to do it in a different color. That way it's easier to see. We're going to rewrite it, and we're going to factor by grouping. So the two numbers that we came up with were negative 10 and positive 11. So I'm going to write here negative 5x, and then squared. And then we're going to put positive 11x, negative 10x, and then plus 22, all equal to 0. So again, these are the values that we came up with. So when you do factor by grouping, you're essentially breaking apart this term right here, okay? And we're rewriting it as 11x minus 10x. And again, the order does not matter, okay? So I could have written these numbers here and here in any order. It doesn't matter. I could have written the negative 10x first and then the positive 11x. It won't matter. You're going to get the same answer in the end. So from here, you should have 4 terms. You do. Go ahead and group them. So group the first two, then the last two, and then look to see what your greatest common factor is that you can pull out between your first grouping. I can pull out an x. So I'm going to go ahead and pull out an x. That will leave me with negative 5x and then plus 11, okay? Now look at your second grouping here. What can I pull out here? Well, I can go ahead and pull out a positive 2. So if I pull out a positive 2, I get plus 2, and that will leave me with negative 5x and then plus 11, okay? So that's your confirmation. Your common factor is the same. You're pretty much done with the problem now. So you're going to write your common factor one time, which is right here and here. So rewriting it one time, it's going to be negative 5x plus 11, and then times your outside value. So x plus 2. And again, this is all equal to 0. And you're pretty much done. All you have to do now is solve these factors, and you're done. So again, you're going to take each factor individually, solve it by setting it equal to 0. So looking at my first factor here, I have to move over 11, making it negative 11, and then divide by negative 5. That will give you x is equal to negative 11 all over negative 5, right? But we have two negatives here, so it becomes positive. So I'm going to rewrite it as 11 over 5. So 11 over 5. There's one solution. The other solution, look at your last factor here, If I take x plus 2 and I set it equal to 0, that will give me x is equal to negative 2. So I get x is equal to negative 2, and here we go. Okay, now we do have to check to see if one of them is going to be extraneous. So let's go ahead and scroll up to the original equation, and let's do 11 over 5 first. If I plug in 11 over 5, anywhere on my denominators, will it lead to division by 0? So looking at this denominator right here, well, if I plug in 11 over 5, wherever I see an x, I'm not going to get a 0 there. Same thing here, I won't get a 0 here. And same thing here, I'm not going to get a 0 here, right? If you do negative 2, well, go back to this denominator right here. Well, anywhere I plug it in here, I am not going to have division by 0, right? So that checks out. It will also check out here because remember, it's a negative 2, not a positive 2. So if you do negative 2 times 4, that's negative 8. So it's like a negative 8 and a negative 8, that's negative 16. So you don't get 0 there. And same thing on this denominator here. So those are actually going to be our solutions. We do not have any extraneous solutions here. And that's how you would check. You just go back to the original, plug it into your denominators, and make sure that you do not have division by 0. All right. So that is it. I hope that you gained something from the video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.